What if everything we had believed for centuries was wrong? What if the Earth itself was not the center of the universe, but only one planet among many circling the sun? In the early 16th century, a quiet, unassuming man from Poland dared to suggest such a thing. His name was Nicolaus Copernicus. Copernicus was no fiery revolutionary. He was not a soldier or a politician. He held no armies, no throne, and no great power in worldly affairs. Instead, he was a scholar, a mathematician, a physician, and a canon of the church. Yet it was through this very humility and through his devotion to study that he would come to overturn one of the most deeply held beliefs in human history, that the earth stood still at the center of the cosmos. For thousands of years, civilizations had gazed at the night sky and built explanations of the heavens. The ancient Greeks, led by philosophers like Aristotle, insisted that Earth was immovable, while the sun, the moon, and the stars revolved around it in perfect crystalline spheres. Later, the great astronomer Claudius Ptolemy created a mathematical system to explain this geocentric view. His model, written in the 2nd century, used complex arrangements of circles upon circles, epicycles, to account for the movements of planets. Though awkward and at times inaccurate, the Ptolemaic system became the foundation of astronomy for over a millennium. By the Middle Ages, it was not merely science, it was dogma, accepted by the Church and woven into theology itself. This was the world into which Nicolaus Copernicus was born in 1473. His hometown of Turin lay within Royal Prussia, under the protection of the Kingdom of Poland. The city was a thriving center of trade, filled with merchants and craftsmen. Copernicus's family belonged to this merchant class, and he grew up in relative comfort. But his father died when he was still a boy, and his education and future were placed in the hands of his uncle, Lucas Watson-Roda, a powerful bishop in the Polish Church. Through his uncle's influence, Copernicus gained access to the finest schools and universities. He first studied at the University of Krakow, where he encountered the foundations of mathematics, astronomy, and philosophy. He was taught under the shadow of Aristotle and Ptolemy, for their systems still dominated European thought. Yet even in Krakow, the intellectual winds of the Renaissance were stirring. Ancient texts, once lost to the West, were being rediscovered. Works from Arabic scholars who had preserved and expanded upon Greek science filtered into Europe. Copernicus entered this world of debate and rediscovery at exactly the right moment. When he was about 10 years old, his father's death had made the church a central force in his life. This shaped him in two ways. First, it provided the security and patronage he needed to pursue study. Second, it tied him to an institution that would later be both his protector and his greatest obstacle. For while the church nurtured scholars, it also guarded its authority fiercely. To question Ptolemy was, in some ways, to question the order of creation itself. By the late 15th century, contradictions in the Ptolemaic model were already apparent. Planets like Mars did not always follow predictable paths. To account for this, astronomers had added layer upon layer of complexity, circles upon circles upon circles. For Copernicus, this seemed inelegant, clumsy, and unworthy of the divine order he believed God had created. Surely the universe must be simpler, more harmonious. This dissatisfaction would become the seed of his great idea. After his early studies in Krakow, Copernicus traveled to Italy, then the center of Renaissance learning. In Bologna and Padua, he studied law, medicine, and astronomy. There he met Domenico Maria Novara, a professor who dared to criticize Ptolemy openly. Novara encouraged his young pupil to observe the heavens for himself. Together, one night in 1497, they measured the position of the bright star Aldebaran during a lunar occultation. Their result did not match Ptolemy's predictions. It was a small inconsistency, but for Copernicus, it was proof that the old model was flawed. Over the years, Copernicus continued to think and to write. Sometime around 1514, he composed a short manuscript called the Commentariolus, or Little Commentary. It was not published but shared privately among a few scholars. In it, he laid out his bold idea. The Earth was not fixed. It rotated daily on its axis. It traveled yearly around the sun. The stars were not revolving around us. They were fixed, unimaginably distant, while it was the Earth itself that was in motion. The simplicity of the model was breathtaking. The retrograde motions of planets, so awkward to explain under Ptolemy, became natural consequences of Earth's orbit. Instead of many circles upon circles, Copernicus's system offered harmony and order. Yet he knew such an idea was dangerous. To dethrone the Earth was to dethrone humanity's place at the center of God's creation. For now, he kept his ideas quiet, releasing them only in whispers and manuscripts among trusted colleagues. But the idea had been born, and once born, it could not be silenced forever. Part 2. The Conflict. By the early 1500s, Nicolaus Copernicus had fully developed his ideas about a sun-centered universe, but the world around him was still firmly grounded in the old ways. Europe remained deeply attached to the Ptolemaic geocentric model. For centuries, this system had been taught in universities, woven into church doctrine, and reinforced by centuries of tradition. To challenge it was not merely to challenge science, it was to challenge the social and spiritual order itself. Copernicus lived and worked in Warmia, a semi-autonomous region of Prussia, under the protection of the Church. As a canon of the cathedral in Frauenburg, he had obligations to the Church, but also the freedom to study, observe, and write. For years, he quietly made observations of the planets and refined his calculations, measuring the motions of Mars, Venus, and Jupiter with painstaking care. His goal was not rebellion, it was accuracy, order, and truth. Yet the very act of questioning the geocentric system was inherently dangerous. Scholars risked not only ridicule, but condemnation. The intellectual environment of the time was deeply divided. On one side were the traditionalists, university scholars, church authorities, and theologians who defended Aristotle and Ptolemy. They believed the Earth was fixed, at the center, and that any evidence to the contrary threatened the moral and religious fabric of society. On the other side were the reformers, humanists, and emerging astronomers who began to question ancient authorities. These scholars emphasized observation and mathematics over unquestioned tradition. Copernicus positioned himself cautiously among them, aware that any overt challenge could provoke serious backlash. Despite his caution, his ideas began to circulate. By 1514, he had shared his Commentariolus with a small group of trusted colleagues. The manuscript outlined the revolutionary concept that the Earth rotated daily and revolved around the Sun yearly. It explained retrograde planetary motion as a natural result of Earth's movement, eliminating the need for convoluted epicycles. Among the scholarly circle, the manuscript was met with fascination and skepticism alike. Some recognized its brilliance, while others dismissed it as speculative and dangerous. Copernicus's contemporaries were divided not only by belief, but by personality and ambition. Some scholars were eager to adopt the new model, hoping to gain fame for correcting centuries of astronomical errors. Others, loyal to tradition, actively resisted. Rumors circulated that a heliocentric universe would contradict Scripture, undermine the Church's authority, and diminish humanity's place in creation. In this tense intellectual atmosphere, Copernicus's work was both celebrated in secret and feared publicly. By the 1520s and 1530s, Copernicus began preparing a more complete version of his work, eventually titled De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly spheres. This was no simple pamphlet. It was a comprehensive mathematical and observational treatise. He worked meticulously, refining his models, verifying planetary positions, and writing in the careful, precise Latin that scholars of the time required. The work combined centuries of accumulated knowledge with his revolutionary ideas, creating a system that could withstand scrutiny, but would still challenge centuries of accepted wisdom. Yet even as he prepared his masterpiece, Copernicus hesitated. He feared the reaction from powerful authorities, both religious and academic. He lived in a conservative region where deviation from orthodoxy could provoke censure. Scholars urged him to publish. Friends praised the elegance of his system, but Copernicus remained cautious, aware that history had already shown what could happen to those who dared to challenge established beliefs. The rising tension was both personal and intellectual. Copernicus knew that if his work were published too soon, it might be attacked, misinterpreted, or dismissed. Yet delaying also risked leaving the discovery to someone else. Around him, Europe was changing rapidly. Universities were expanding, Renaissance humanism was flourishing, and scholars were increasingly willing to challenge ancient authorities. The stage was set for a confrontation between tradition and innovation, authority and observation, faith and reason. It was in this charged environment that Copernicus took the final steps toward publication. By the early 1540s, he entrusted his manuscript to a young mathematician, Rheticus, who had traveled from Germany to meet him. Rheticus recognized the significance of Copernicus's ideas and encouraged their dissemination. Slowly, cautiously, the long-suppressed heliocentric theory began its journey into the wider intellectual world, a journey that would change astronomy, science, and human understanding forever. By the 1540s, Nicolaus Copernicus had completed decades of observation, calculation, and careful writing. His heliocentric theory was no longer a private thought. It had matured into a comprehensive mathematical and astronomical work. He titled it De Revolutionibus Orbium Celestium, or On the Revolutions of the Heavenly Spheres. Yet the world was still not ready. Europe was deeply conservative, bound by centuries of tradition and by the authority of the Church. To suggest that the Earth moved was not a minor scientific correction, it was a profound challenge to humanity's perceived place in creation. Copernicus understood this. For years he hesitated, wary of public scrutiny, fearing censure or misunderstanding. The turning point came with the arrival of Georg Joachim Rheticus, a young mathematician from Wittenberg. Rheticus traveled to Warmia to study under Copernicus, and upon seeing the manuscript, realized the monumental importance of the work. He encouraged Copernicus to share his discoveries more broadly, arguing that the elegance and accuracy of his model deserved recognition. With Rheticus's urging, Copernicus reluctantly allowed his manuscript to be prepared for publication. In 1543, the year of his death, De Revolutionibus finally appeared in print in Nuremberg. The work was dense and highly technical, filled with tables of planetary positions and detailed mathematical proofs. Copernicus did not write it as a polemic. He presented it as a careful study, a system that explained observations more elegantly than Ptolemy. He included a preface, added by the editor, suggesting that the model was merely a mathematical convenience, a subtle effort to shield the book from potential accusations of heresy. Despite this cautious approach, the publication ignited controversy. Some scholars recognized the brilliance immediately. The heliocentric model simplified calculations, eliminated convoluted epicycles, and predicted planetary motion with remarkable precision. For mathematicians and astronomers, it was a revelation. Others, however, were unsettled. Clergy and traditional scholars feared the implications. If the Earth was not at the center, what did that mean for Scripture, for theology, for mankind's position in the universe? The intellectual conflict was immediate. In universities across Europe, scholars debated the new model with intensity. Some attempted to reconcile Copernicus's ideas with church doctrine, suggesting that the sun-centered system was a hypothetical tool rather than a literal truth. Others dismissed it outright, seeing it as a dangerous challenge to centuries of accepted knowledge. The heliocentric system became a lightning rod for discussions of authority, faith, and reason. Copernicus himself did not live to see the full storm his ideas would unleash. He died in 1543, shortly after the book's release, quietly confident that he had at least left the world a new way of thinking. His death, however, did not end the debates. Scholars such as Galileo Galilei and Johannes Kepler would later take the Copernican system further, providing observational evidence and refining planetary motion. What made the publication of De Revolutionibus so revolutionary was not merely the model itself, but the mindset it demanded. The universe was no longer a fixed stage with Earth at its center. It was dynamic, vast, and ordered according to natural laws that humans could observe and understand. Copernicus had shifted the paradigm from geocentric certainty to empirical inquiry, paving the way for modern science. The climax of Copernicus's life, therefore, was not dramatic in the sense of public spectacle or confrontation. It was the culmination of decades of patient observation, careful calculation, and quiet courage. The moment when the truth he had nurtured finally emerged into the light of print. From that moment, nothing in astronomy would ever be the same. Nicolaus Copernicus did not live long enough to witness the full impact of his revolutionary ideas. He passed away in 1543, the same year his De Revolutionibus was published. Yet the seeds he had sown began to grow almost immediately, transforming astronomy, science, and the way humanity understood its place in the cosmos. In the years following his death, scholars debated, refined, and tested his heliocentric model. While some dismissed it as purely theoretical, others embraced it as a tool for understanding the heavens with greater accuracy. Among the most influential figures to build upon Copernicus's foundation was Galileo Galilei. Using the telescope, a new instrument at the time, Galileo confirmed many of the predictions of the heliocentric model, observing moons orbiting Jupiter and the phases of Venus, phenomena impossible to reconcile with the old geocentric system. Johannes Kepler took the Copernican system further, discovering that planetary orbits were not perfect circles, as Copernicus had assumed, but ellipses. This refinement not only improved the predictive power of astronomy, but also reinforced the underlying principle that the universe operated according to laws that could be understood mathematically. Isaac Newton would later formalize these laws of motion and universal gravitation, cementing the heliocentric worldview that Copernicus had first proposed. The immediate reaction to Copernicus's work was mixed. The Church, initially cautious, eventually placed De Revolutionibus on the index of prohibited books in 1616, largely due to its apparent contradiction with Scripture. Yet despite official opposition, the ideas spread rapidly across Europe, carried by scholars, students, and printed editions. Universities debated them. Observatories measured them. Slowly, the heliocentric model became more than a theory. It became the foundation for a new scientific approach, one rooted in observation, mathematics, and empirical inquiry, rather than unquestioned tradition. Copernicus's legacy extends beyond astronomy. He challenged the very way humans thought about their place in the universe. For the first time, Earth was seen as a planet among many, not the center of creation. This shift forced a profound intellectual and philosophical reorientation. It laid the groundwork for the scientific revolution, a period when observation, reason, and experimentation began to replace dogma, superstition, and blind adherence to authority. Moreover, Copernicus demonstrated the power of patient, methodical study. He worked quietly for decades, making careful observations, refining his models, and resisting the urge to sensationalize his findings. His approach became a model for scientific inquiry: observe, calculate, theorize, and test. Copernicus showed that true revolution in understanding often comes not from forceful confrontation, but from the relentless pursuit of evidence and logic. Centuries later, his name would become synonymous with courage and thought. Copernican would describe not only his heliocentric theory, but also the act of challenging deeply held assumptions and daring to view the world differently. Artists, philosophers, scientists, and educators have drawn inspiration from him. The very act of looking at the stars, calculating their movements, and imagining a universe in which Earth is not the center remains one of humanity's boldest intellectual leaps. The Copernican revolution reminds us that understanding the world is a gradual, sometimes perilous process. Ideas that seem radical at first may become the foundation of knowledge for generations. Copernicus's quiet courage and meticulous study demonstrate that true insight requires patience, discipline, and the willingness to question what everyone else takes for granted. In the end, Copernicus did more than describe the motions of planets. He shifted humanity's perspective, transforming our understanding of our place in the cosmos and opening the door to centuries of scientific exploration. He showed that even the simplest idea, the Earth moves, can change the way we see the world forever.